In the quest to explore the universe, our greatest ally is the Hubble Space Telescope. No scientific instrument in history has revealed so much or taken us so far. Perched above the distorting veil of Earth's atmosphere, Hubble sees what we cannot. Using vivid color to represent scientific data, Hubble paints pictures of unprecedented clarity. Pictures that bridge the domains of art and science and form a direct link between the most powerful forces in nature and the human spirit. In the beginning, there was light. So much light that when the universe formed, every corner of space blazed white hot. But it didn't last. As the infant universe expanded, it cooled and its light faded. For 200 million years, darkness reigned. And then, light was reborn. It was gravity that gave the universe its new look. Gravity drew matter together into vast swirling clouds. While deep inside the clouds, dense concentrations of matter coalesced and began to glow. As these concentrations grew, the pressure and heat at their cores became enormous. Until, with a flash, nuclear reactions ignited. Suddenly, a new kind of light was shining in the universe. The light of countless newborn stars. When you think of the elements that make up a painting, you might think of color, form, subject, but you probably don't think about the light that lets you see the painting in the first place. In space, it's just the opposite. There, light is the subject, especially the light from stars. In fact, it's the way starlight interacts with the matter around it that makes the universe so revealing to astronomers. The Hubble Space Telescope reminds us that in a universe painted by starlight, beauty and science often come hand in hand. Like no other instrument, the Hubble is built to explore the finest details in the light that it gathers from the stars. Where does starlight come from? In the core of each star is a natural nuclear power plant that turns hydrogen, the most abundant element, into helium. This reaction releases energy, much of which works its way through the star's interior until it's released as light. Once starlight is traveling freely through space, it can illuminate the star's surroundings, which may absorb, reflect, and re-emit the light in countless ways. This includes lighting up any gas left over from the star's formation. Normally, this interstellar gas would be transparent, but when it's energized by nearby stars, it becomes ionized and emits light of various colors. Here on Earth, the same principle lights up a city street at night with colorful neon signs. Gas may add color to Hubble's canvas, but it's dust that creates some of the most striking views in space. The dust comes in the form of microscopic grains, no bigger than particles of smoke. But when trillions of them get together, they block and absorb light. Our galaxy is full of dust, and when there's a cloud of glowing gas in the background, the dust stands out in dramatic silhouette. One of the best-known examples of this effect is the celebrated Horsehead Nebula. From a distance, it appears like a horse-shaped hole carved out of the surrounding gas. But looking more closely, Hubble reveals the Horsehead Nebula as never before. A towering pinnacle of dark dust so vast, it would take a beam of light 2 years to cross from the tip of its nose to its mane. Such dark clouds are often found in regions where new stars are forming. They are full of elements like carbon and silicon that are essential for creating solid rocky planets like Earth. Once, the rocks and dirt that make up the ground beneath our feet began as tiny grains of dust swept into a dark cloud like this one. If all dust did was block light, it would still make the universe a more beautiful place to look at. But dust can also do something even more interesting. It can scatter light. To witness this remarkable spectacle, the Hubble cast its gaze across our home galaxy, the Milky Way, to a star so brilliant and so distant, its light takes 20,000 years to reach us. Normally, such a star would appear as nothing more than a faint speck of light. But this star is a giant, one of the brightest in our galaxy. It is also on the verge of running out of energy. And like a dying flame, it surrounded itself in a smoky cloak of dust. In early 2002, the star brightened suddenly and then faded. As Hubble watched, the brilliant flash produced what astronomers call a light echo. Month after month, Hubble recorded the initial flash of light from the star as it scattered and reflected off the surrounding dust. Viewed in sequence, the result creates the illusion of a cosmic flower in bloom. Closer to home, this sequence of Hubble views of the planet Mars shows the dramatic effect of scattered light. Normally, the surface features of Mars make for an easy target with the Hubble, until a planet-wide storm wraps Mars in a cloak of fine airborne dust. The Pleiades, a nearby cluster of stars also known as the Seven Sisters, plows into a cloud of dust while on its trek through the galaxy. In this image, taken by a ground-based telescope, you can see the dust scattering the light of the cluster's young blue stars. Moving in for a much closer look, astronomers have used the Hubble to explore the dust in fine detail. The telescope has revealed wind-swept features that are caused by the force of the star's bright light pushing the dust back. The idea that light can move matter may seem surprising, but it comes straight from the most fundamental laws of nature. Light carries energy, and when light is absorbed by fine particles of dust, the energy makes the dust recoil in response. When this simple effect plays out on the grand scale, it means that starlight isn't just the painter of our universe, it's the sculptor as well. Nowhere is the sculpting power of starlight more apparent than in the fabulous Eagle Nebula. This dramatic Hubble close-up shows part of a dark column of dust silhouetted against a background of glowing gas. Stars are forming before our eyes in this delicate dusty pillar, even as it is shaped and eroded by the intense light from other stars within the nebula. Hubble's unprecedented view of the Eagle Nebula offers vivid proof of the powerful force that light can exert. Like a desert wind that builds and shifts mighty sand dunes, here, light is the invisible hand that guides both the creation and destruction of pattern and complexity in space. Everywhere we look in the universe, our view is determined by a graceful intertwining of matter and light. When viewed at the scale of an entire galaxy, the glowing clouds of gas that are lit up by the energy of newborn stars stand out like snow-capped mountains, while the tendrils of dust that thread their way between the star-forming regions look like networks of lakes and rivers. Pulling back, Hubble shows us how these patterns of light and dark shape our impressions of what galaxies look like, and provide key insights into our understanding of the forces that create their appearance. With Hubble, we can see that we live in a universe not only painted by light, but one where masterpieces abound, and where a powerful telescope can reveal the hidden beauty in every faint patch of light glowing far off in the night sky. An accomplished artist does not spring into being fully formed. It can take years of practice and exploration before a creative talent matures and is ready to tackle big subjects on a big canvas. So too with the Hubble Space Telescope, which has been in orbit around Earth and capturing images of the heavens for nearly 2 decades. Yet, despite a long and colorful career, it is arguably only now that the Hubble is producing its greatest masterpieces. One reason for this is that the Hubble was originally designed to provide the sharpest, most penetrating view of the universe possible. But this means it cannot see more than a small portion of the sky at any one time. A single frame of Hubble's most advanced camera would cover less than 1/10 the diameter of the full moon. And that means some of the most interesting objects in the universe are much too large to fit in Hubble's field of view. When Hubble was launched, astronomers had a long list of things they wanted to see. Now that Hubble's seen them, astronomers have the luxury of being more creative. That means using the Hubble to capture images that are both wonderfully sharp and breathtakingly large. In principle, it's easy to do. It just takes time. With time, you can point the telescope over and over at adjacent portions of the sky. This leaves you with dozens of separate images. But when assembled like a mosaic, they become one giant picture. When you're trying to take in something as vast as the universe itself, it's an approach that can't be beat. That's precisely what astronomers decided to do when they wanted to get a sense of what the entire universe was like when it was less than half the age it is now. First, they chose a relatively empty corner of the sky that was largely free of stars and nearby galaxies. The best place to do this turned out to be just off the corner of the Big Dipper, one of the most recognized star patterns in the night sky. Compared to the Big Dipper, the area astronomers examined is small, a narrow strip that can easily be covered up with an outstretched finger held up against the sky. But to capture even this small a slice of the universe, Hubble had to take more than 500 separate images using a variety of different filters. Ultimately, all of this information was assembled into one giant mural, a cosmic group photo that includes at least 50,000 individual galaxies. To let your gaze wander across this single strip of the night sky is to experience our universe in all its vastness and variety. Only Hubble could create a view like this one, a view that opens up more of deep space to the human eye than any other image in history. Looking more closely, Hubble has found that this random sampling of galaxies contains surprising diversity. Some of the galaxies are spiral-shaped, like our own home galaxy, the Milky Way. Yet others appear jumbled and distorted. These galaxies are still under construction. Because they are so far away, their light has taken billions of years to reach us. Hubble sees them not as they are now, but as they were billions of years ago when the universe was just emerging from its tumultuous beginnings. Much closer to home, Hubble's ability to build a mosaic out of many smaller frames means that we can witness the assembly of an entire galaxy on our cosmic doorstep. This galaxy is smaller than the Milky Way, but it's relatively close. Instead of taking billions of years, its light takes a mere 12 million years to arrive here, so it makes an ideal subject for the study of galaxy formation. Like its more distant counterparts, the galaxy is not a graceful spiral, but a bright and chaotic jumble of stars. Its irregular appearance is the result of a collision between smaller galaxies that gravity has pulled together to make a larger system. This forced collision has triggered a dazzling burst of star formation. Here we see thousands of young stars, along with splashes of diffuse pink light, the glowing clouds of hydrogen gas where new stars are being born before our eyes. From the universe at large to a single galaxy, Hubble has revealed beauty and insight at many levels and over great distances. But perhaps its greatest masterpiece comes from its exploration of the nearest star-forming region to Earth. The light from the Orion Nebula takes just 1,500 years to reach us. It's even faintly visible to the naked eye as part of the constellation Orion the Hunter. A pair of binoculars is enough to reveal that it's not an ordinary star, but instead looks more like a small patch of mist in the sky. Around the world, telescopes for years have revealed that patch of mist as an impressive nebula where new stars are being born. But until now, no telescope has been able to show us the Orion Nebula at this level of detail. More than 500 Hubble images were used to create this exquisite mosaic. Through Hubble's eye, the nebula is revealed as a vast, billowing field of gas. Its structure is like an oyster shell, opening toward us. At the center is the trapezium, a cluster of 4 intensely bright giant stars, 100,000 times more luminous than our own sun. These stars produce enough ultraviolet radiation to energize the surrounding hydrogen and light up the inner portion of the nebula like a flame inside a lantern. These stars also generate powerful winds of high-speed particles, which are pushing at the gas and gradually driving it away from the center. With the Hubble, astronomers can now study every wrinkle and fold in the nebula's complex structure to better understand this process. To gain even further insight, the Hubble image has been combined with an infrared view from the Spitzer Space Telescope. It shows more activity and structure in regions where the gas is too cool to glow in the part of the spectrum visible to the naked eye. The colors that add so much beauty to the image are also the key to understanding the chemical composition of the nebula. Wisps of green light are partly due to atoms of sulfur, while some of the red light around the outskirts of the nebula is produced by chemical compounds that are rich in carbon. And there is more. In one of its most celebrated discoveries, the Hubble has confirmed that the Orion Nebula represents a new generation and a new beginning for thousands of stars. When Hubble searches among the nebula's feathery filaments, it finds ample evidence that new solar systems are being created here, much the way our own solar system came into being billions of years ago. Looking at this magnificent image, just one among so many great views from the Hubble, we come, in the end, to a deeper realization. It's not simply abstract beauty that draws us to this masterpiece, but a feeling that within its glowing wonder is an underlying truth that tells us something about where we came from, a truth that connects us directly to the universe we observe.